Okay, so last time we kind of covered a very boring stuff, right? All the fork system call about creation of processes. As we know that the return value of the fork system call is very important. It's determined whether it is a child or a parent. So you can go back a few pages. Okay, what happened to my sensor? Okay, so I have to move the computer closer. Okay. So here is about the return value of a fork system call, and the core of the fork system call is duplicate. Okay, we duplicate processes. Okay, when it duplicates the processes, it will duplicate many things. Like what? Like the program counter. What I mean the program counter means is the point that the program is executing. So you start with main and then all the way down to the fork system call. Then by the time you duplicate the program counter, it means that the program will duplicate the position that the instruction were executing. Okay, so it means that there may be more than one processes up. And the program code itself is duplicated, the memory. So I demonstrate in the class that we do malloc, okay, and duplicate the process. And two pieces of memory are being duplicated and separated, okay? And the open files I told you to try, but I believe that no one will try, no problem. Okay, later in this chapter, I think it should be chapter 2.5. Okay, we'll go into this problem. What happens if I allow the process to before fork? Okay, you create a file, okay, and then you duplicate it, and after duplication, you want to write something to the same file. What will happen? Okay, and it is perfectly fine in the operating system and it's allowed, because the operating system don't care about the output is making sense or not. Okay, so this is duplication. And oh, what happened to my sensor here? Okay, I extend a little bit. Oh, I don't have any USB here. Okay, so forget about it. And the things that are not duplicated is listed in tables, so I hope that you will read it by yourself. Then we'll go to program execution. Last time we talked about the program execution has a scenario like this. The scenario is here. When I execute a program, it's perfectly fine, right? It's follow your order. You tell the system call for execlp. Execl. Okay. It tells him to execute a /bin/ls. And last time in the lecture, we also talk about what is the meaning of s/bin/ls. When you type ls, you execute something. And last time I already tell you there is a command called which. The which command is telling you that, hey, when you type ls, what exactly is being called? It's actually calling help from this program called /bin/ls. Okay, so there is a file. Okay, you can rm it, and when you rm it, okay, yeah, you can rm/bin/ls. Of course, I cannot, okay, because it's strike protected. Is the permission should be granted from the root so that I can remove it. But I'm not the root, so I cannot remove it. Okay, so don't remove it. Remove it. You have to reinstall a system. Okay, now what is going on here? Before I talk about what's going on here, I have to cover one more stuff before I go on. Okay, so what are the things? What happened? I drained out the battery again. I have charged it. Okay, so yeah, there's a little trick. Remove battery and we insert it, then it will gain the power back. Okay, come on. Hey, next time I have to find a Okay, so it should be alright. Huh? Yeah. Okay, well, two slot now is okay. So here, what are they? The first command I already tell you about this is a program you want to execute it. Now, why I have to repeat it again and put a note here? So now I disclose to you the reason. The reason is about this guy. Okay, so it's kind of hard to see the stuff. Wait for a moment. Yeah. PS1, sorry. PS1. Okay. So let's take a look at this program. This program, the name is not important. What is more important is about these two stuff. How many of you have made use of them? Only one. Good. Okay. I learned it in my year 1 course. Okay. During that time, we don't use Microsoft. Okay. So Microsoft sucks. Never need those guys. If you need those guys, it will be disaster. Okay. If you know and you have tried, then you know that Visual Studio is a piece of crap. Okay. So here is something that really important that you have missed from your previous study. Okay. In case that you're already year 4 student, sorry, you lost a lot of things. Okay. What is this two guys? This two guy has name. Okay, so I spell it out. Well, the first guy is called ARGC. It's actually equal to argument counts. Okay, so there is number of arguments. Okay, and what is ARGV? Okay, ARGV is argument factor. Okay, so the factor means an array of pointers, and each pointer point to a string. So you can imagine that is an array of string. So I put 2 asterisks here because array, then you need 1 asterisk. But so happen that each array elements point to a string, so it's another asterisk here. So double pointer stuff here. And what is these two guys combined together? Okay, I hope that you understand after I run this program. Okay, so let me continue to explain this. So what is this for loop? This for loop is looping through the amount of argument counts. Okay, so let's say argument count is 5. So it's loop for 5 times, and every time it will visit this array of pointers. Okay, this is an array of pointers. Okay. Oh, by the way, I have a figure. I forget about the figure. Okay. So what is the meaning of array argument vector? The argument vector is something like this. Okay. So it's an array item number 0. Point to a string, array number 1 point to another string. So I said that there's an array of string, look like that. Okay, and we continue. We loop through every argument, and I just print it out because I know that there's an array of string. So you use %x to print it out. Okay, so let's run this program. You can also run it. Okay. But not in Visual Studio. Okay, I don't know how to configure that piece of crap. Okay. So, once it says something like this. It seems to be strange. If I type A, B, C, X, 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 Y, 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 haha. Can you guess what it is? Yeah, I don't type so many. I type sorry. I just type haha, hee. Okay. Can you guess what it is? Can you guess? What is this? It is something inside C program allows you to access what? Yeah, this is inside the program. This is outside the program, right? When I type the command, of course, definitely it's outside the program. Okay? When outside the program, we type something like this, and inside the, I should say inside the program, right? Inside the process. Inside the process, when it's executing, it assess the thing that you supply to them. Okay, so this is the arguments. Okay, you supply the arguments, but you don't know how many arguments are there, right? So the argument counts here is 0, 1, 2, right? The argument count here is supposed to be 3. Although I put 2 arguments here. Okay, so how can I count? Is an array of number of stuffs here. 1, 2, 3. So 3 items. So it says 3, and that's why we call it the arguments. Vectors, and this vector will grow. How it grow? It's grow by you supply more arguments. Then next time I execute it, it will change, right? The first time I execute it, I didn't supply anything, so I said 1 guys only. Second time I execute it, I supply 1, 2, 3, 4, 5 guys. So it's loop for 5 times, and so on and so forth. So it's adopt to the moment that you execute a command. I should say the command, okay? Because command including the program name together with a list of arguments. Okay? So what can you imagine about the LS program? Actually, the LS program is following this rule. You type LS minus L. LS minus L like this, but I replace LS with my program. Then actually to LS minus L is a string. Okay? And take this string, understand that, oh, you supply this string to me. Okay, so I know that you want a longer list of outputs, so it is just a input argument to change how it performs the job. Okay, so this is the arguments. And what can you say about argument 0? Argument 0 is always repeating its name, and it doesn't relate to the program name. So as this program is a code name, okay? Although I compile the code, call this code, what is the name of the code? Do you remember? This ARG, maybe I put it down a bit. Okay, so this is the code name. This is the compile file name, okay? So actually this argument 0 don't have any relationship with the code, but have the relationship with the moment that you execute a program. So what is the meaning? I do the following. ARGS, I call this XXX, okay? So do you know what I'm doing? I do a copy, okay? I copy ARGS, ARGS into another name called XXX. Previously it doesn't appear in my directory, so I do a copy here, and I execute XXX. Then ARGV0, the first guy, will be named as a string with a ./XXX. It don't care how you compile it. It care about the binaries that you create. We call it binary file, or an executable file. Then you create. When you create it, you fix the name. Then we will call this name. Okay. So this is something advanced. How many of you have heard of symbolic link? Only a few want to, like this, okay? So just like a shortcut in Windows, okay? So if you have heard of symbolic link, then I will do it now. First I remove the XXX now. Okay, ls again. I do a symbolic link to link the source to something. I call it ls. Okay. Then you will find a new items here. It calls itself ls, but actually it's pointing to ARGS. And the argument 0, when you execute this fake ls, what can you say about it? Let's take a look. When I execute this fake ls, it will also adopt the time that you type the program. So argument 0 don't care what is the actual binaries or actual executable file. It's care about the time that you type the command. Okay? So you type the command and it will be copied there. Okay? So let's take a look back to my example program. Okay, are you following? Okay, so in Kelvin. Okay, are you following? It's kind of new to some of the students here, but for me it is I should be teaching you in the year 1, but this time it's not. So this is something that you can add to any C program. It's not just for Linux. It can be added to Windows, Mac, okay, no matter what is platform, because it's a C standard, okay. So let's continue. Okay, so we go back to this program. So what this program is doing, this program is actually, this highlight line the system call. So I explained to you what is the first guy. The first guy is the program we want to execute. Now you understand what is the second, it's kind of understand. The second guy is actually the argument 0. Okay, so you supply the argument 0. And you've seen previously in a demonstration, the argument 0 is always equal to the name that you execute a program. Okay, I choose this name. So I duplicate the same name here, so this argument 0. Now what happens if I don't have further arguments? I'll put a noun here to say that, oh, I stop the list now. So we can try to modify this program in the following way. So this program is called exec example.c. Okay, so this example, I will modify now. I know the pickle is more easier to see because the color is better. Okay, so I change the program in the following. -L. Add one more argument when I want to execute this program. So what is the expected output? Expected output will be something like this. You want to execute this guy, and this guy supposed to start reading the argument list when it starts executing. And the first argument 0, supposed to be equal to its name. So I duplicate it. Then it finds there is one more argument 1. which is minus L. So it will add accordingly and give you another look of the ls program. Execute that. See, it's changed. It's changed in this way. Now, what happens if I change it again? Change it again to minus A, showing hidden files. Okay. Compile and then run. So it looks changed. Okay. One of the hidden files. These two are the hidden files. Okay. Sorry. This and this. Okay. These two guys are hidden. So what can you expect from this execute system call? It's actually become a way to pretend to be you are working in the shell. Okay, the shell accepts a list of arguments. Actually, what you are going to do in writing the program, you know what is the program you want to execute. So I put the name here, and then I repeat it by copying here, and you type some more argument to me. So I will concatenate them into here and making the list longer, longer, and longer. Okay. So of course I can change the previous program into the following way. Add one more. Okay. Add one more. So it's become minus A minus L, as if I'm typing this. As if I'm typing this. Okay. So there's a look when I type this. Now I compile and run. Without the color, okay, but you find exactly the same thing. So the dot and dots here, and looking at this previous look, the dot and dots are also there. Okay, so this is the execute system call. The execute system call means that it allows you to execute a program with arguments, parameters. Okay, or let's say that you write something, you need a file name, okay, you supply a file name. As long as it's a string, it's okay. So, this is the illustration, okay, the illustration that I just play on Linux. Any problem, are you following? Okay, so maybe this is the first time you've heard of that you can access the list of arguments in the program. Okay, maybe this is the first time, so if you have any problems, interrupt me. All right. So what I'm going to do next, I will try to explain this, okay? But last time I already talked about it, right? Because it's kind of easier to understand. Now, when I execute this program, let me change it back to the original look. So, original look. It's like this. Compile and run. So there's something like this. But when you take a look at the program, after executing the call here, there should be one more line saying after this call and say a message. Before it, I will have a before message, so you will see the before message, no problem. But where is the after message? Last time I already explained to you, but if you were very sleepy, so you can hear it again. The problem is very simple, okay? What is so simple about this is the mechanism of this execute system call is not go to that program, execute it, and come back to your original program. The mechanism is a little bit strange. The mechanism first is you have to remember one very important point is a process when you execute it, there is a program attached to it. So as if you are following a list of commands, okay? I give you a list of commands, you read it all, execute this, execute this. So this is a paper, okay? So when I call execute system call, that means I pick away the paper on your hand and give you a new set of commands, another paper. So this is the truth about execute system call. So I change the paper on your hand. Then you start reading the paper, and the paper, when you read it until the end, it tells you to kill yourself. Exit system call. So what is exit system call? Exit system call means the program should die, or the process should die. Okay. So when the process dies, you don't have any way to come back to the original program. So this is the reason that why the after call, the after message cannot be shown, because the process is already dead. So this is the reason. Now we will go into more details about the execute system call. It will be a little bit trouble in understanding this because it is a bunch of bunch of a table here. But before I show you this table, okay, we do a short summary. The short summary about this execute system call is actually it is switching from a program to another. So what is the side effect when you do the switch? I mean side effect. The side effect is it's not just changing from one program to another, but you will also throw away many things. Okay, when you do the switch, you will throw away all the memory that allocate to you. What's the meaning? The meaning is, let's say in the original program, you have a global variable, let's say 1 megabyte long. Okay, then after you switch to another program, that program actually don't need any global variable. So what should you do? You have to throw it away. Okay, don't want it, or that 1 gigabyte, no, 1 gigabyte, not a megabyte, okay? 1 megabyte original buffer, and when you do a switch, so happen that an other program also need 1 megabyte. But should they be inherit? I don't think so, okay? Because the memory location of that 1 megabyte of the original program may not fit the new one, okay? So that action is actually not actually the meaning of throw away, okay? It means that we will reset the entire user memory, the memory for you, okay? You executing the program, just user memory. I will throw it away, and we create the new image. So why we need to do it, okay? Because the memory requirements is all compiled in the program, okay? So when you switch from one program to another, you have to throw it away. And the register value, because you are executing something originally, but yeah, let's say the program counter, or the instruction pointer point to assembly code which line you're executing, but no more. You switch from one program to another. So all the register value will be thrown away, okay? And others are preserved, like PID. You are switching from one action list to another action list, but you are still you. So your identity won't change. So you are still that process. And other time it's just accumulating like a process relationship is like, so it's inherit, okay? And the running time is also inherit after you call this call. Okay? So any problem? If you have any problem, make sure that you interrupt me, because this is kind of a strange call. I should think it's hard, but it's strange. So we come to a big family of the call. Okay, so what is this family? The execute system call is not alone. It's not there's only one type of execute. There's totally 6 types. Okay, so how to read this big table? The big table is actually telling you that we have the same prefix of this 6 call. What is the same prefix? exec. Okay. So exec is the same prefix, so that's why I love to call it an exec system call family, okay? Because it's the prefix is the same. Now, what is the remaining alphabets, in the postfix? Now, the alphabet you can see approximately 4. I can count the empty set, 4 variations. Whether you have L, whether you have the L or P, L or V, I should say, L or V, 1 variation. Whether you have E, E means the environment. Whether you have P or you have no P, okay, so the empty set is also counted. Now, what is the variations here? Let's take a look at the purple guy first, okay? The purple guys are with the P or not the P. So you can see some code with P, some code don't have P. So it is used for when you specify the file that you want to execute. So how many of you can distinguish these 2 guys? A path name and a file name. So let me give an example. So what is a path name versus a file name? So path name means you have to give the green guy the entire path to me. Or you can specify only the last part as we call it the file name. So what is the difference? Let's take a look in a program. So I picked just 2 guys. Let's say this guy versus this guy. So exec-l, exec-lp. So you look at this program. So which version is using? It's using exec-l with the p. Okay. So what's the meaning of the p? I need to modify the program. So this modification is quite important to you. So I will check if this call is successful. Every system call, I say mostly every. Mostly every system call, when it fails, it will return -1. Okay? So if I check that if we turn -1, that means the execution failed. And let's say if it's failed, so that's why I said it's important to check whether the system call failed. I will use the, how many of you have used p-error before? No one. Okay, so I change it in another way. Okay, later on I will use p-error, don't worry. Yeah. Oh no. Okay. Yeah. So that means you will expect that if it's return -1, that means the execution failed. And then I will say, oh no. Now let's try something obvious. So what's the obvious thing? There shouldn't be any program called /bin/xxx, okay? Shouldn't be. I don't expect I will have this program. So, and I execute it. Oh, so first you may need to take a look at here. Okay, so I change it. I compile it. I don't care about the first argument because argument 0, I should say, because this is fail. It shouldn't be found. Then when I execute it, it will say, oh no. Okay? And because the switch failed, so I can show the after. Okay, because the switch failed. Okay. Now, with this in your mind, I will change the following. You know, every time I type a ls command, I don't type /bin/ls, right? So how about I change /bin/ls into ls, whether I can execute it successfully or not. Okay, so cat like this. What can you say? What can you say? What can you say? Sorry, I cannot say anything because I have an ls here. I'll remove it. Okay, so again, cat execute. Yeah, there is no ls file in my directory here, so it won't execute. But does this seem strange, right? Because you already know that when I using this command, I type ls, it can be executed. Okay, so it is actually highly related to how we use the execute system call. When you use the execute system call, you specify the call with this version, then it will expect that you will give it a full path. And this is not a full path. I type ls. Now when I type ls, it will think that, oh, you're talking about from your current working directory, I look for the ls. But in the current working directory, there's no ls, so I found fail. So what if I want the system to search for me? Yeah, you go on to search for ls, I don't care. Okay, I don't care whether my current directory has ls. So you will add a p here and let the system to search for you. So let's go up. Hey, where is it? Okay. So get a p here. Now this time I have to change it because I know that it will be executed. Save. Compiled, no problem. So I need to cat it out. Alright, let's go. See? It's executed. Now, what is the difference? The difference is I change it into P and it allows the system to, not the system, the OS of course. The OS to look for, hey, where is ls? I don't think it's inside your current directory. So I want to go into somewhere else to search for it. Later on I will tell you where the execute system call will start to search, okay? But eventually find out ls and execute. Okay, so this is the difference between this path name and the file name. Your special file name is successful because you add a p here. Now, what is the difference between these two guys? These two guys has variations whether you have an L, here is L, or a B. Okay, so what is the difference between these two guys? One is called argument list, one is called argument vector. So what is the meaning of argument list? It's already shown here. It's a list of arguments. Okay, and think about it. If you are asked to write a program to accept a command, Okay, I want you to write a program accept command. And command the number of arguments that you cannot predict. Okay, I can give you a command with 100 arguments. What can you do? Can you, before the not before, after compilation, can you grow this list? You cannot, right? You cannot write a program to produce another program and compile the program again. You understand what I mean? Yeah, you cannot grow this list on the fly. Okay? So what can you do? So the system call sucks. Yeah, this is the conclusion, right? You cannot grow. What I did do, we compile the program when I run the program. Does it mean stupid? There's a chicken and egg relationship here. So don't worry, we have another version of this execute family. Okay? So another version is you don't use the L, but use the V. Okay? So you can find it, the brother relationship, just a little difference. And what is the V here? The V here means you don't give in a list of arguments like this, okay? But give in an array, okay? You can do your malloc stuff, doesn't matter, okay? But the structure must be, first you create an array of pointers. And then for each pointer, you point to a string. Then it will be able, what happened to, is my computer making some sound? No? Okay. So so this is the construct. That's why Kelvin talked about it in the tutorial. Okay, because later on you have to construct it by yourself. Okay, I give you a list. Okay, of arguments. Then you reconstruct it back into something like this, and put this array into this location, and it was just that. Now this is the moment that you can grow the list dynamically. Okay. Let's say I type in ls, so you will only have the argument still ls and then the none. Okay, this is the none is very important to tell the system that yeah, we stop there. Okay, so I don't have any example here. I rely on Calvin to talk about it. Okay, so any problem? Shouldn't have any problem, huh? Because you didn't try it. So what is the last guy? The last guy is a ye here. So what's the ye? Ye is a kind of hard. Why is it hard? Because what you have just known, okay, is about these two guys. You have just heard of these two guys. Now I suddenly tell you that, yeah, there's not just two guys. Yeah, there is the third guy here. Okay, so what is the third guy here? The third guy here is what we call the environment list. Okay, if you have gone to my workshop, okay, in a last first day, we talk about arguments. Environments. And this is the list of environments. You can try executing this program, okay, by yourself. But in our design of the coming assignment, actually you don't need. You don't need this. Okay, you don't need this. We will design so that we will skip this ye part. Okay, so ye part means that it will rely on a provided environment. So, what is the meaning of using a provided environment? Let's do a search over this guy. Okay, so I do a copy and Google, do a search. What happened? execve. Okay, so there's the guy. Search, take a look, and then you will find this guy with 3 inputs. One, the file name you want to specify, then the argument list that you want to supply to the program, and it has the third guy. The third guy is the environment that you modify. Okay, so we will control the assignment so that you don't need it. Okay, so you can always use what we call the original environment. So in a later assignment, you will only use execv and then p. Okay, because we love to use ls instead of /ls, right? So you will stay focused at this call. So this is the execute family. Any problem? Any problem? If you have any problem, make sure that you ask. Okay. So something more extra that is about the environment. Okay. We can set a lot of environment in our shell. So let's take a look at the environment core. This is some typical examples, but I don't want to play with this guy. So Echo means printf, okay? I can print path, okay? The path environment variable, okay? So the path environment variable is to control why I can type ls and execute /bin/ls, okay? Because why? Because inside this environment variable called path, there is, let me check. I found you here, okay? So the delimiter of this list is colon. So every time you match a colon, that means the end of a directory and the start of the next directory. So you will find /bin/local/sbin one directory, /bin/local/bin another one, and you keep on looking, and then you find /bin. So that means when I type ls, the system will go to this environment variables inside your execution environment. That is the shell. The shell has this guy stored inside its memory, and this OS, the kernel, will search 1, 2, 3, 4, 5, 6, and up to the 6th element is finally find ls. There inside there is an ls, so it will execute /bin/ls accordingly. Okay, so this is the mechanism, and then we'll go into something important. Okay, this is very important. Why is it important? Because you already understand that the execute system call. So I put an asterisk here. Let me say that under this prefix, I don't care about the postfix. Okay, I talk about execute system for family, and the execute system for family kind of doing bad job because it's kill process. It's originally executing a very good program written by me, and then you switch to another program and don't come back. And it's not just don't come back, you die. Okay. So we don't want it. Actually, we want to establish something like this. What is that? This is our roadmap in executing a program or a command that you supply to me successfully, and then come back to your original execution environment. Now, what's the roadmap? The roadmap is look like this. I have the green guy supposed to be the parent or the original program. The original program start execute. Okay, and when you're doing this execution, you implement the flow like this. I read input, okay, using getS, fgetS, scanf, I don't know, okay, but you take input from the standard input. Then you find that, there is a program I want to run. So I prepare something, let's say I change the string into an array, so and so forth. Then I call fork. And the new process is for the execution of the program that you specify. Okay, I call fork. Then this orange guy start executing the new program using execute system call. Okay, and after it's finished executing that program using execute system call, it will die because it's by the design of the execute system call. You never go back because that program say that you should die. So it dies, and the parent is sold. So what is the look? Okay, the look like you accept a command, and then it run, but you wait until it's finished, then you come back. And actually, this is the very important call that I don't know whether you have heard of it. How many of you have heard of this? The system library call. Maybe you don't. I write the program, then I may be able to recall your memory. Okay. So let's do this. I call it test.c. Okay. So whenever you write this, sorry, the waiter is very cold. I typed very slow. Okay. So this is for the system library call. System library call. Okay. I don't know whether you have heard of it or not. I don't need it. I just no, not fork. Sorry. It's system. No, it doesn't make sense. It's ls, okay? Okay, or you don't like ls, you may like to have a child buffer. I'll make it very large, okay? And getS, buff, is it like this? I don't like getS, I like scanf, okay? Scanf, buffer, and change this into buffer, and then return. Before return, make sure that I say goodbye. Yeah, good manner. Right, let's do it. Yeah. Catch. Make this. Run. Now, it's waiting for me because it's there's a scanf, right? I type ls. It works. Now, any goodbye there? Yeah, we've had goodbye. Do it again. Something wrong. Maybe haha. Shouldn't be any program called haha. Yeah, then they say, oh, haha, not found. Okay, and goodbye. Try one more. Try. Oh, reboot. No. I will definitely reboot my program. Reboot my system. No. Let's say the yes, the yes program are shown. Okay, so you keep on running, right? Because the next program didn't finish. Okay, previously I tell you that there is a program called yes and keep on printing stuff. Okay, now what is this program is about? I Control C is first. So when I Control C is, then it understands that oh, you just terminate the program, just you want to start it and show you goodbye. Now this is something we want, right? Does it look good? And this is already provided. Sorry. This is already provided in the system is a standard library.h. Okay, and the inside is actually using a bunch of system call. It uses fork system call. It uses execute system call, and also one more. That guy is. Sorry, let me go back. That guy is about wait and resume. The wait and resume, we need one more system call to control it. So the fork, the execute, and the system call here is called wait. The three systems will combine together will be that system library call. We will try to implement the system library call in tomorrow. Yeah, tomorrow. Tomorrow in the morning. Hope that tomorrow is not that cold and you will come. Yeah, 9:30 is a big challenge, I know. Okay.